Today's lesson is, it's talking about how two triangles are congruent, but by using, let me rephrase that. They're both on a coordinate plane, which means no measurements were given to you, no marks, no angles. It's up to you to prove that they're congruent. A lot of work for these problems. And if you don't show me the work, it's just a 0 for it. Even if you get the right answer on a test, if you have no work or you're right, I guessed, guess what? You got a 0. They did that. Yes, on the last test. That's the reason why they're laughing right now. So, I must see the work. I'm telling you now. That's just the way it is. It'll be a lot. I'm going to show you different ways. So let's start off with just copying the distance formula and Pythagorean theorem. Now for Pythagorean theorem, it says must use a right triangle. That doesn't mean the picture has to be a right triangle. It means you must create it off to the side so you can use a squared plus b squared equals c squared. I'll explain what that means in one of the problems again. So before we go on, here's an example of what's going to be done today. You can be given a coordinate plane with a picture of a triangle. And another picture of a triangle. You do not have to write this down. Your job is to prove that they're the same. Now, what are 5 methods that we have? Side, side, side. Side, angle, side. Angle, side, angle. And hypotenuse leg. Now, you can do Pythagorean theorem to find that all the sides are the same. Therefore, side, side, side works. You can use a method to find out that one of the angles are right angles. But can a triangle ever have 2 right angles?
No.
No. Which means you're only able to find out one angle if possible. So is this an option anymore? No, because you can't find 2 angles. These 2 aren't options. This one is. And if it's a right angle, what's my other option? If I pick doing angles, I must show the work that they're angles. If I pick that they're sides, I must show the work for the side. I'm going to explain it all because here's how much work I did for the first problem. I'm going to go through it one step at a time with you. Now that the complaining is done, let's get started. And 5, 4, 3, 2, 1. Copy this down. So, to prove it's a right angle, it means that the lines are perpendicular. Perpendicular means that they cross at a 90-degree angle. In order to prove that, it says the slopes are going to be opposite reciprocals. Opposite means if one's positive, the other one's negative. If one's negative, the other one's positive. Reciprocal means flipped. So, a little example. If I said that one was 3/4, what would the other one be? Not just 4/3. Negative 4/3. It has to have the negative sign. If one's positive, one's negative. Because they're flipped and they have opposite signs. What if it was -4? Flip it. It's 4 over what? 1. So you flip it to give you positive 1 over 4. So what it's saying is if one line rises by 3 and has a run of 4, which looks like this for you guys. There you go. Rise of 3, run of 4. And the other one has a rise of -4 and a run of 3, and they will cross to make that right angle. That's what we're going to use to prove that they're right angles. Now, do I have to use angles to prove that two triangles are the same? What option do I have that doesn't need an angle? Side, side, side. For the sake of showing you an example, I'm going to do one with an angle on the first problem. It's not needed for the other ones. You can pick if you want to use it or not. Do we have this copied down because you won't see it again? Alright, example 1 or 2. So, little note in the middle I'm going to add is the only angle you can measure is a what angle? Right, good. Therefore, your only options are side, 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 side angle side, and hypotenuse leg. Just because it is a right angle, does it mean I have to use hypotenuse leg? No. I can use both legs to make it side angle side. Just throwing that out there. Go ahead and draw those two triangles on your paper and label the points as A, B, C, and P, R, S. Alright, looking at triangle ABC, do any of those angles look like it could possibly be a right angle? What if I turn it? Which one? B. B looks like it can be a right angle. Which means which one on the other triangle looks like it could be a right angle? R. Our job was to prove that they're right angles if you want to go that route. For the sake of me showing you an example of angles, I'm going to say that they are. So here's what's going to be done to prove it. First, I'm going to keep my work organized. I'm going to write slopes. In order for B to be a right angle, the line AB and BC must have opposite reciprocal slopes. How do we find slope? Rise over run. So the slope of AB, how much does it rise? 3. Use a different color for that. How much does it run? 3. Therefore, my slope is 3 over 3. What does that reduce to? I'm going to leave it as 1 over 1, but 1's correct. Just so I have rise over red, I can see when it flips. Makes it easier. What should BC be to make it a right angle? What should the slope of BC be? Huh? Negative what? Negative 1 over 1. To show that it's flipped and the opposite sign. So for BC, what's my rise or my run? It goes to the right how many? How many down? If it's down, what kind of 6 is that? Negative. So my rise over my run. What does that reduce to? Negative 1 over 1. Are these two opposite reciprocals? Yes, therefore angle B is what? So now to prove that angle R is a right angle, I'm going to do the same thing for PR and RS. PR. What's my rise?
3.
What kind of 3? Negative 3. What's my run? 3. Which makes it negative 1 over 1. RS. RS is what? 6 to the right, 6 up, makes them both positive, which makes that 1 over 1. Are those two opposite reciprocals? Yes, therefore what? Angle R equals 90 degrees. If you read the directions state, determine whether each set of triangles is congruent. If they are congruent, state the theorem. Then justify your answer and state 3 pieces of evidence. We just found 1 piece of evidence. We just found that angle B is congruent to angle R. Tell your angles are the most work. Sides are a little quicker. Just a little. Shave off a few seconds. Alright. Now that we know it's a right angle, pick side angle side or hypotenuse leg. Hypotenuse leg I heard first.
Which one's faster?
I won't answer that one. For hypotenuse leg, do you want to start with matching the hypotenuses or matching the legs?
Legs.
Which leg? A, B, or BC? So you want to prove that BC is congruent to which one?
RS.
RS, good. Okay. So, now for sides. BC to start. So, if I'm just going to do... Let me go back. Do any angles look 90 degrees? Not at all, right? No, which means my only option is what? Is there a side in triangle DEF that I can just count?
Yeah.
Which one?
D.
DF. DF is flat, so you count just 1, 2, 3, 4, 5, 6. How about in HJK? That one is 5. Now, before you just shout out an answer, actually think about this. Just because those two don't match, does it mean that my triangles aren't congruent?
Yes.
Who said that DF has to be congruent to HJ? Could DF be congruent to HK?
Yes.
That's an option, right? So we can't just assume that just because one pair of sides don't match, they're not congruent. So here's what's going to happen. You're going to find the sides for just one whole triangle. Now, if neither of these two here equal 5, then are the two triangles the same?
No.
No. So once again, you're going to find the sides DE and EF. If those two do not match HJ, which is 5, then there's no way that these two triangles are the same. Any questions?
Say it again.
If DE and EF, if neither of those equal 5, that means that this side isn't the same as any of these three sides, which means it can't be side, side, side for any reason. So you're done. So go ahead and find the length of DE and EF. So for DE, it's 5 squared plus 2 squared equals C squared. 25 plus 4 is how much? So C is the square root of 29. Does that equal 5? No. EF. 4 squared plus 5 squared equals C squared. 16 plus 25 is? Does that one equal 5? What does this mean? All three sides don't match. Therefore, the triangles are not congruent. Do I have any questions? Does this make sense for this last question?